Alright, chat, we're doing this again. Here we go. Give me a second. Real bear.
Slaughterhouse just traded with 8 viewers.
Yo, Slaughter. Weak out right now, you're good. 8 something. So today, chat, we're gonna be doing this once more. Does she have about GD or something? Alright, how do you say we get cooking? We gotta get moving. Hello, Seanzilla. Alright. Respiratory system I'm thinking of. I think it's a good idea to just catch up on all of that poo. Okay. Yeah, let's just get started. I guess. Let's just do what we have to do here. Let's take a step back. Maybe look at some digestive structures. Very fun stuff, I know. Okay. 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 Focus. Come on, SquishyMan. What are we doing? These are... gastrin. Hormone produced by the lower part of... Okay, hold on. Produced by lower part of stomach. Which... So it enters the bloodstream and then it stimulates the upper stomach. Stimulates gastric glands to produce pepsinogen and hydrogen chloride. And then... Mm-mm. And then they react together to produce pepsin. Why doesn't it just produce pepsin on its own? Why does it have to, you know, drop the two chemicals then put them together? I don't get it, bro. So it digests the proteins into peptides, which is confusing because I thought that was done later on by secretin, but we won't worry about it. And duodenum. So hydrogen chloride can burn the gut lining because it's not some crazy pH Mabroskis. So a mucus layer produces to prevent that from happening. This is why your stomach kinda hurts whenever you vomit. Or it's like, you know, it's kinda like acidy because it's because of the acid in your stomach acid. Okay, the pyloric sphincter. It's the little muscle which closes off the lower part of the stomach. Allows small amounts of chyme. My question is, how do they not make the stomach acid go down there? This is a question that will not help me, but I'm curious. It does let it pass. That's the point. Hold up. So, the thing is, okay. So pretty much it does let the hydrogen chloride down as well. It's just that that's what makes the acid chyme so acidic. And then the pancreas just, you know, uses its sodium bicarbonate to neutralize the pH, even more than that, make it basic, and get it to 8.5. Okay. Great. We're not doing math. I don't know what you guys are talking about. We ain't doing that. This isn't a graph of math. I know there's the delta and the x. I know you guys see that, but it isn't actually it isn't that. It looks like it is, but no, this is also, what function would this be anyways? This is pretty much just this is just well, this is energy, the y-axis is energy, reaction path is, you know, it's just enzymes, where this lower line is when there's an enzyme present, and this upper line is when enzyme isn't present. So pretty much the energy of activation is a lot lower on the enzyme, just because it's an enzyme. So anyways, let's lock in here. And no, literally isn't math. Bro. it's not math. Pancreas produces enzymes and sodium bicarbonate. Well, pancreatic juices. Isn't that what it means by enzymes? Probably, I guess. Gallbladder stores the bile. Okay, hold on. So the duodenal wall produces secretin and cholecystokinin. And the secretin stimulates the release of pancreatic juices, which break down the proteins and do all of that. I think did I list the yeah, I did. Pancreatic amylase, which is starch to, I think, maltose. Yeah. And then trypsin, protein of peptides, lipase is fat droplets to just the monomers, fatty acid and glycerol. Cholecystokinin stimulates the release of bile from the gallbladder, which breaks down fat. Does that break the doesn't bile just break down the... Hold up. It emulsifies fats. Right. Okay. Zoink did not just get... No, you guys are lying. You guys are lying. You guys are lying, bro. Oh my...
I'm so sad, bro. That's actually so sad, bro.
The following mods are incompatible. Like, what are we talking?
Bro.
Bro, I'm actually so sorry, bro. That's...
No, stop, bro. It's so...
Wait, go. Zug.
Come on,
Oh my god.
He's got that.
Okay, focus. Anyways, so pretty much, gallbladder stores bile, secretes small intestine, liver produces bile to emulsify fats. Duodenal wall produces secretin and cholecystokinin. Secretin, I gotta memorize this. Secretin, well, the duodenal wall produces two hormones, there's secretin and cholecystokinin. Secretin, secretin, bro, secretin stimulates the release of, pancreatic juices in the pancreas, and the, yeah, them pancreas be releasing them juices, yo. Which, pancreatic juices like pancreatic amylase, which is starch to maltose, trypsin, which is protein to peptides, and lipase, which is, fat droplets to, fatty acids and glycerol, the monomers. Cholecystokinin stimulates the release of bile from the gallbladder, which just emulsifies the fat. Okay, noted. Got it. Okay, we memorized it. Now, yep. Yeah, so we memorized these here. Let's get into small intestines. Oh, we never finished this unit. That's crazy. So active transport is done in order to retrieve the stuff. So glucose and amino acids are sent to the are absorbed via, well, this is in the it's the small intestine. These are the villi, and these are the microvilli. On each villi, not in each villi, that's plural. In each villus, glucose and amino acids are absorbed via active transport, sent to the liver. And what else does happened? What else happens, chat? I forgot what happens. That thing is sent to the liver. Yes. And then, fatty acids and glycerol are done with some. Enter the lacteals, which go back to the bloodstream later at the subclavian veins. Right. Aren't the subclavian veins the things on the heart at the top? Subclavian. Yeah, the ones at the back. Right. And we're gonna get into that later. So the appendix is the useless mofo. Once thought to be vestigial organ, but yeah, a remnant of evolution, no longer necessary. It was supposed to be used for it was a safe room for commensal bacteria when the body's under attack for harmful bacteria. I thought it was like where bones go or something goofy like that. Anyways, okay, hold up. So the appendix is no longer necessary. Why didn't you just get rid of the appendix? Rip it out! Rip out the appendix! Alright, lock in. So, large intestine, or the colon, just absorbs water from the undigested food. They have E. coli in there somewhere that also get extra stuff the body missed? Is that what it is? Yeah, live off of any substances that are not digested. It's just bacteria that lives in your gut. These E. coli break down substance, and then they give off the characteristic odor of poo. It says feces, but I want to say poo. Yo, what's up, everybody? How we doing it? Hope everybody's having a good day. Make sure to donate so I don't have to do this for the rest of my life. Anyways, the rectum is the poo, the big stinky poo hole. No, that's the anal sphincter. I got it wrong. No! Okay, yeah, I got it. Large intestine. Oh, I feel like I understand that. Okay. Okay, those are some digestive structures. I think it's an idea to... We already went through enzymes, didn't we? I thought we did. Wait. No, I know I did. Salivary amylase break down. Yeah, come from the salivary glands, and they just break down food, sorta. Don't they? secrete in the mouth. Acts on starch. Okay, so it breaks down starch into molecules of maltose. Later broken down. Pancreatic amylase. Axon starch converts it to maltose, but that happens in the duodenum, so it's different. Maltase break down maltose to glucose. Bile emulsifies fats. Not really an enzyme, but an emulsifier. Yeah, blah blah blah. Lipase. They spelt it wrong in the example. What the nuts? So yeah, it breaks down fat to its monomers. Nuclease break down RNA and DNA to nucleotides, and then the nucleosidases break those down into sugar, phosphate, and base components, I guess? Yeah, that makes sense. Okay, some enzymes. Let's look at insulin, glucagon again. Then I think we're good with our review here. Insulin is the hormone secreted by the pancreas? Oh, it's by the pancreas. Oh, weird. Is it negative feedback? What is this? So, insulin produced by the pancreas secreted when blood sugar is high. Okay. And pretty much, yeah, secreted when blood sugar is high, and then it makes the liver and muscles take up extra glucose and glycogen, whatnot. And it promotes synthesis of protein. Okay. Production of why? Para qué? After your body switch to break things down. So insulin is produced. Subchill person. So yeah, insulin's produced. Makes those mofos oh yeah, sorry, I'm being stupid. Okay, yeah, I got it. Glucose and glycogen. Yeah. Glucagon should be vice versa. The pancreatic hormone that is secreted when blood sugar is low, usually in between like durations after a meal, causes liver and muscles to break down glucose and glycogen and glucose, and that stops protein fat synthesis. So it raises blood sugar levels. Fire. Major functions of the liver. So, did I write these down somewhere? I thought I did at some point. Chat, did we do the functions of the liver? I can't remember. If not, I'm just gonna do them here. Liver be like, and then we're just gonna do what it does. Turns. Produces urea. I still don't. Is it urea or urea? Urea makes sense.
Urea.
Urea. Urea. From the breakdown amino acids. Breakdown. Okay, hold up. Mix. So that's deamination. What else do you do? Damn, bro, the liver does everything. Makes blood proteins, so makes wait, hold on. Proteins found, so albumin, globulin, fibrinogen. So, antibodies, osmotic pressure. I swear we were gonna learn about albumin later. Whatever. Makes blood proteins from AA, detoxifies blood. Right. We're not going to learn about that, aren't we? All I know is it has something to do with extra stuff in the smoothie of the cells in the liver. Something extra that does. Converting them to harmless substances. Metabolizing poisonous stuff. Okay. So destroys this old RBCs, probably not functioning anymore, converts it to hemoglobin. Makes bile, of course. Stores glucose, glycogen, I know that. Makes urea from okay, hold on. What is the chemical formula of urea? So from what, amino acids? From amino acids. The detox job. So pretty much so you break down amino acids. Liver removes the NH2. Oh, removes the amine group and then that's deamination. when you break down amino acids, yeah, so the liver removes the amino group. And now it's toxic because now it's ammonia, so you quickly convert it to urea. And urea is NH2 CO and H2 CO. Okay. Right. Keto acid, oh, that's a thing. And then, ammonia enters the urea cycle. So multiple steps, use ATP, the end result is urea. Less toxic, that's all it is, less toxic. Amino acids into urea, so it's less toxic. Why wouldn't it just keep the amino acid? Oh, I see. So it does keep some amino acids, but it doesn't save all of them because, like, we don't need all that. Instead, just might as well use space in the body to store fat and energy and whatnot. Okay. So it does that. Blood proteins, like albumin and all that. From amino acids, I bet we're going to learn about that. Because we're going to go into respiratory system any minute, you know. Any minute now. So it detoxifies blood by removing the bad stuff. It just, yeah, metabolism, all that. That's all the liver does, bro. Hold up. They're saying the gallbladder has no purpose. That's tough. Well, can't the gallbladder just like... I mean, it still stores bile. That's kind of necessary. What? Yeah, so the gallbladder is still necessary. Well, it's not necessary, but it's preferred because you're gonna be kind of cooked without a gallbladder. Just less efficient to emulsify fats and whatnot. Okay, I mean it just stores bile. That's all it does. Right. Okay, we got it. Back to enzymes, because I feel like I don't know enzymes enough. I don't know what I'm talking about. I don't like it. Hello? Ain't loading. Okay, digestive enzymes. Wait, no, I did do this. Wait, what? I was just in... What? Okay, so... So... The substrates bond to the, well, active site, yeah. There's also, what about inhibitors? Wait, so metabolic pathways are complex. Right. There's non-competitive and there's competitive inhibitor. Right, I remember those, like heavy metals or temperature. No, that's not really a... So just like lead or mercury, yeah. Competitive inhibition. Right, I remember this. Temperature around 40 degrees, speed of reactions. Right. Okay, I kinda remember. Yeah. Alright, let's move on to, perhaps... next unit. Yay, respiratory system, chat. We're gonna do respiratory system. Yeah. But I do remember liver-like turns RBC into hemoglobin. It produces bile, makes urea from amino acids. It what else does it do? It's just called deamination. I wouldn't have to know more than that, would I? Metabolizes poisonous substances. Makes blood proteins. Stores glucose and glycogen. Okay. Respire. Okay. Let's get moving. So, Glottis. You say swallow it. Breathe there. That goes there. Okay. I get you now. I get you now. That goes there. This goes there. Okay. I get you now. Ferrex just thought of that. Alright. So, conchial, membranes. So, cleaning debris have two parts, which is, you know, cilia and mucus deal with it, and then cilia and mucus lining. Anything but air will be caught in the mucus. Therefore, we breathe easy. Yeah, so if something's at the back of the mouth, we will swallow it, cough it up, or spit it out. No other choice. You're not gonna die. Your brain refuses. Anyways, adjusted body temperature. Man, I'm tired today. Sup, crabs? Yeah. So stretch receptors. I don't think I'm in the mind space to study right now, actually.